Okay, now question 6 gives you a set of information and a blank graph, and the most important information you have here is are the points. So at x is -2, your function value is 1, and we might gather from this scale that if this is 3, then since there are 6 increments between the origin and 3, each one of these is a half. Each increment here is a half, and so this is 1/2, 1. So this is y equals 1, and this is x equals 1, 2, 3, 4, 2, because this is a half, -1, -1/2, -1, -3/2, and -2. And so we have a point there. And then at when x is -1, the y value is 3, the function value is 3. When x is 0, the function value is 2, the y-intercept is 2. When x is 1, y is 1, so we plot a point there. And when x is 2, x is -1. And the 2.5 there tells us that this is 2.5. It's there just to help us with the scale. And I think I mentioned in class, I took this graphic from the text because I could never satisfactorily recreate it myself, because this function doesn't actually really exist as a polynomial in any neat fashion. There are very weird numbers, coefficients, and whatnot that would give us this, but that's for another class in the future. So you have the points, and now all you need is to compare the increase-decrease and the concavity, and you can see that from -infinity to right here at 0, and this does not mean that it's 0 here. This means that the value of the second derivative is 0. And so concavity changes there, down to up, concave down, and at 0 it changes to concave up. And you don't have to draw, like I said, you don't have to exaggerate that. You just have to show a curvature that does have a sort of upward facing curve. And you can imagine if it keeps on curving like that, it would curve up eventually, but it doesn't. It changes right here from positive to negative, so once again we are turning down, and so that matches the concavity there. So if you compare this graph to the increase-decrease and the concavity, you can see that everything matches as your sketch on the exam should. Okay, now question 7 asks us to calculate absolute minima and maxima, the absolute minimum and maximum, if they exist for this function on 2 given intervals. Now to do this, we take the derivative of the function and find the critical values. And then we evaluate the function, not the derivative. We evaluate the function at each of those critical values and at the endpoints. Well, here's the derivative. So we bring the 4, it's just the power rule. We bring the 4 around front, 4x. 4 minus 1 is 3, so this first term is 4x cubed. We bring the 2 around front here. 2 times -18 is -36. And 2 minus 1 is 1, so this is x to the first. So -36x is the second term, and then there are no other terms that have an x in them. This is just a constant, a number, and so it differentiates to 0. So our derivative is 4x cubed minus 36x. And the greatest common factor, we set this equal to 0 to factor, and the greatest common factor is 4x. When you factor a 4x out, you have left behind in the parentheses x squared minus 9, which is the difference of two squares, which we should all be able to factor very easily. Square root of the first is x, square root of the second is 3, and so that factor then appears twice with a plus between one pair and a minus between the other, and so that is our factorization. And we evaluate the function now at these endpoints, -4 and 4, and these critical values, 0, -3, and 3. 0, -3, and 3. And I went ahead and evaluated at 1 because that's one of the endpoints in the other for the other interval. And so at -4, now we're just looking at A first at the first interval, and so at -4 the value is 0. At -3 the value is -49. At 0 the value is 32. At 1 the value is 15. At 3 it's -49 again, and at 4 it's 0. Well, this tells us that the absolute minimum is -49, and it appears twice at -3 and +3. That's what it says here. And at the maximum, if you look at all these values, the maximum is 32, and that appears at 0. So the absolute maximum is 32, and it's at x equals 0. And the absolute minimum is -49, and that appears at ±3. And I think, again, on the exam, there are places for you to fill in those values. I don't know why I didn't put them here in the solutions. Maybe I was in a hurry and was lazy. This set of solutions in this practice exam is a few semesters old. I've used it 2 or 3 times. And so then that's the first interval, -4 to 4, and then on the second interval, 1 to 3, you now can ignore the -4, and for that matter, the -3, and the 0, and as a matter of fact, the 4. So the only values we're looking at are the values at 1 and 3, and so the maximum is 15 at x equals 1, and the minimum is -49, and that's at x equals 3. Okay, question 8 is going to ask us to minimize or maximize some value. We want to find out what the smallest or greatest value is on a particular interval for a particular function. Well, this function gives us fuel economy of a compact car, and this is the function that gives us the fuel economy. And so we want to find the minimum and maximum, or rather not the not the minimum. We want to find the maximum, the absolute maximum on that interval. And so we're doing the same thing we did in question 7, but it's just a word problem. And so you can just look at the function and realize that you're just going to do the same thing you did in 7. And so we take the derivative, multiply 2 times -0.015, which is then -0.03. And you subtract 1 from 2, so that's x to the first. So -0.03x is the first term, and this is a linear term, and as we've seen many times before, you just bring the coefficient down to the derivative there, and you set that equal to 0 and solve. And setting it equal to 0, you add 0.03 to both sides, and that gives you 0.03. That is 0.03x to both sides, and so that gives you 0.03x is equal to 1.14. Divide both sides by 0.03, and you get x is equal to 38. So that's our critical number, And so we evaluate at the endpoints of the interval and at the critical number. And so you evaluate at 20, and that gives us 25.1. So when you're driving down the road at 20 miles an hour, you're getting 25.1 miles per gallon. And at 60 miles per hour, you're getting 22.7 miles per gallon. But at 38, at the critical value, the absolute maximum of this function on that interval, 20 to 60 inclusive, is 29.96. And so that is where fuel economy is greatest. It's greatest at 38. At what speed is fuel economy greatest? At 38 miles per hour. Okay, question 9 probably involves more work than any of the other questions, but I'm hoping it won't be too terribly daunting. Everything should be pretty straightforward here. We should be familiar with cost functions, which are just lines, y equals mx plus b, except the y is cost as a function of quantity. And so we will need the cost function and the revenue function, and they are easily assembled using the facts from the text of the question. So variable costs will be this m times x. Variable costs will be m times x, and so that's the variable costs are the cost for manufacturing each item. In this case, bicycles. So it's $70 to manufacture each bicycle, and x is the number of bicycles, so m times x, 70 times x are the variable costs, is the variable cost portion of this function. And the fixed costs are just stated. Fixed costs are $100 per day. Now you don't need to worry about, pay attention to the per day, per week, per month. That won't figure into, it won't affect how you work this question, work this problem out. So our cost function, cost as a function of quantity, is 70x plus 100. Revenue, we should recall, is price times quantity, or quantity times price, as it's shown here. And the price function is given right here for this question. Quantity will just be x. So quantity is x, you multiply by the price, x times 270 minus 10x. Then, to determine profit, you subtract your cost from your revenue. And so that revenue is x times 270 minus 10x, or negative 10x squared, plus 270x. That's what that would be if you multiply that out. And when you subtract cost, don't forget to distribute the negative to both terms. So negative 70x and negative 100. And 270 minus 70 then is 200. And so 270x minus 70x is 200x. So the profit function is negative 10x squared plus 200x minus 100. Then, since you are trying to maximize profit, you take the derivative of that function. 2 times negative 10, it's a polynomial, so you just use the power rule again. 2 times negative 10 is negative 20. 2 minus 1 is 1, so that's negative 20x to the first, or negative 20x. This is a linear term. X is raised to the first power, so you just bring the coefficient along as the other part of the derivative. So our derivative, p prime of x, is negative 20x plus 200. Then you set that derivative equal to 0 and solve. To solve, you add 20x to both sides, so you have 20x equals 200. You divide both sides by 20, and so that gives you x equals 10. That is the quantity that they should produce. That is the quantity that they should produce. And to determine the price it should charge, the company should charge, you just substitute that 10 into the price function. 270 minus 10x. So little p of x is 270 minus 10 times 10. 10 times 10 is 100. 170 minus 100 is 170. So that is the price that they should charge. And now we're just asked what is the profit. What is the exact amount of that profit? Well, we have the profit function right here. So just substitute the 10 in for each of these x's. Remember, as I've said, when you have an x, put a set of parentheses. If you have an x, put a set of parentheses. Inside the parentheses, substitute the value that you're evaluating the function at. And so that's 10 squared, which is 100, times negative 10 is negative 1,000. And then you have 200 times 10, which is 2,000. And negative 1,000 plus 2,000 is positive 1,000, and then minus 100 is 900. So the profit will be $900. Finally, for question 10, and only for question 10, X does not represent a quantity produced or a quantity sold. It's a number of price changes. How many price changes do we need to make to a particular item in order to maximize revenue? And so we have a sandwich shop in London that sells 1,200 Tomme de Savoie sandwiches per month at a price of £4.50 each. Market survey shows that for every 1/10 of a pound reduction in price, 30 more sandwiches will be sold. So we want to know how much they should charge for a sandwich to maximize revenue. Well, revenue, of course, is price times quantity, and so we use these equations that are provided that I gave you in as a separate handout in class, and that will be that'll be on the actual exam. It'll be page 1, and you just tear it off so that you can have it to the side and refer to it when you get to this question. So, yes, revenue is price times quantity, and price is determined uniquely to this question with this equation right here, and it's this equation for decreases because we are reducing price by 1/10 of a pound. So we charge, the original price is 4.5 pounds, and we subtract, because their price decreases, we subtract the price change, which is 1/10 of a pound, and multiply by the number of price changes. Well, as I said, X is the number of price changes, so this is our price function, 4.5 minus 0.1x. Now for quantity, we also rely on one of these equations. We first have the original quantity here, that's the 1,200 sandwiches that they are currently selling at this price. So that's the 1,200. Excuse me, and we add the additional units sold per price change. That's 30 more for every reduction of 1/10 of a pound in price. Now we don't have a subtraction here because we are increasing the number sold, and that's the number sold times the number of price changes. Number sold is increase rather in number sold is 30 more times the number of price changes. So there's our quantity function, and you multiply these two together. Don't forget to put parentheses around both, and then you multiply using the FOIL acronym. 4.5 times 1,200, that's the first terms. 4.5 times 30x, that's the outside terms. The inside terms would be negative 0.1x times 1,200, and then the last terms would be negative 0.1x times 30x. And when you multiply all of those and simplify, you get negative 3x squared plus 15x plus 5400. So that is our revenue function. That's what we want to maximize, so that's what we take the derivative of, and so we're just using the power rule. So we multiply 2 times negative 3, that gives us a negative 6, and 2 minus 1 is 1, so this term, the first term of the derivative then is negative 6x. The second term is a linear term, and so we just bring the coefficient of 15 in, and the last term is a constant, and so it differentiates away. So the derivative of the revenue function is negative 6x plus 15, and we solve for x by adding 6x to both sides and dividing both sides by 6. And simplified, that gives us x is equal to 5 over 2, which is 2.5. So 2.5, 2.5, is the number of price changes that we should make to or that Frenchie's Baguettes should make to maximize revenue. So you substitute 2.5 into the price function we have up here, the price function we determined from the information and this equation. And so we have an x here, so we substitute in 2.5. 0.1 times 2.5 is 0.25, and you subtract that from 4.5, and the new price should be 4¼ pounds. Now the revenue function is a function of the number of price changes, not price, not quantity. It's the number of price changes. Once again, that's 2.5. So you substitute 2.5 in for the x here, and in for the x here, and you square that 2.5, multiply it by negative 3, you multiply this 2.5 times 15, and you add all these together, and you get 5,418.75. So, with 2.5 price reductions of 0.1 pounds, and this should be a pound sign, not a dollar, but a price of 4.25 pounds will result in the sale of 1,275 sandwiches, which maximizes our revenue, their revenue, at 5,418.75 pounds. So 1275, by the way, is 75 more than the 1,200 they were selling, so that's how many more sandwiches they will sell when they increase their price to 4¼ pounds.